All right, so let's take a look at these problems. We've got 8 problems. The directions are all the same. They want us to categorize each one of these equations as a parabola or a circle or an ellipse or a hyperbola. And we can pretty much do it by inspection. Um, let's, ooh, I do not know how to, don't know how to use this yet. Let's see. All right. So this first one, this number 1 right here. I see a 1 in front of x squared. I see a 1 in front of y squared. Whenever your coefficients in front of x squared and y squared are equal to each other, this is going to be the graph of a circle. Here in number 2, x squared and y squared, yeah, they have a coefficient of 1 in front of them, but they're on opposite sides of the equation. To compare these, I need the x squared and the y squared to be on the same side of the equation. So if I subtract y squared from each side, and then I can see there's a 1 and a negative 1. So whenever the signs are opposite, then I know the graph is what they refer to as a hyperbola. Oops, I did not spell that right. There we go. All right, now here in number 3, I have a 1x squared and a 3y squared. They're not equal to each other, and they're not opposite in sign like number 2 was. This was a positive number that's in front of x squared and a negative number in front of y squared. That's how I knew it was a hyperbola. When the numbers are the same sign, either both negative or both positive, but the numbers are not equal to each other, then I know that this guy is referred to as an ellipse. Here in number 4, I've got a 2x squared and a negative 2y squared. The positive coefficient and the negative coefficient tell me that the graph of this would be what they call a hyperbola. And here in number 5, I've got a coefficient of 4 in front of x squared, a 1 in front of y squared. They're both the same sign, but they're not equal to each other. This is an ellipse. Now here in number 6, I have a y squared term, but I don't have an x squared term. Whenever you just have one variable that's being squared, that's a parabola. And here in number 10, I've got x squared, but I don't have y squared. That's also a parabola. Number 7, that's also a parabola. And here in the last problem, number 8, I have a negative 2 in front of y squared, a negative 2 in front of x squared. Those are equal to each other. And whenever the coefficients are equal to each other, I know that this graph is a circle. All right, so let's summarize real quick on these. On number 1, the coefficients were equal to each other. That's a circle. In number 8, the coefficients were equal to each other. Now, in number 1, the coefficients were both positive, and here it's both negative, but what's important is the coefficients were equal to each other. That's how we knew that those were circles. When I look at the hyperbola, the coefficients in front of the x squared and the y squared are opposite in sign. Here we had a positive in front of x squared and a negative in front of y squared. Those are opposite in sign. That's a hyperbola. Here in number 4, we had a positive in front of x squared and negative in front of y squared. When they're opposites, when the sign is opposite of each other, then it's a hyperbola. For the ellipses, it's similar to the circle. A circle is a special case of the ellipse. But for an ellipse, the coefficients are the same sign. This was positive 1 and this was a positive 3, but the numbers are different from each other. So 1 was not equal to 3, but they were both the same sign. In number 5, 4 was not equal to 1, but they were both positive. They were both the same sign. So it's pretty easy by inspection to see how to answer these. In number 6 and number 7, you only had one variable that was being squared, and the graph of that is a parabola. So it feels awkward with this new software and new computer, and I don't even know for sure if it's recording my voice. So, hey, I hope this helps, and I'll talk to you later.